Om Sri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders and my dear students. Hearty welcome to the special functions class. Today we are going to learn the orthogonal properties of Hermite polynomials. Now we are going to show that the orthogonal properties of Hermite polynomials is given by integral minus infinity to plus infinity e power minus x square hn of x hm of x dx equal to 0 if m is not equal to n, and if m equal to n, the value is going to be root pi into 2 power n into n factorial. So the product of two Hermite polynomials multiplied with e power minus x square between the limits minus infinity to plus infinity is given by 0 if m and n are not equal, and the value becomes equal to root pi into 2 power n into n factorial. Now using the generating functions we have summation hn of x t power n by n factorial, n running from 0 to infinity is nothing but e power 2tx minus t square, and consider another Hermite polynomial summation hm of x s power m by n factorial, m running from 0 to infinity is nothing but e power 2sx minus s square. Now multiplying corresponding sides we get double summation n running from 0 to infinity, m running from 0 to infinity, hn of x into hm of x into t power n into s power m divided by n factor into m factorial. And the right hand side becomes e power 2tx minus t square plus 2sx minus s square. Now multiplying both sides by e power minus x square and then integrating both sides with respect to x from between the limits minus infinity to plus infinity, we are going to get, that is double summation integral minus infinity to plus infinity e power minus x square hn of x into hm of x into dx t power n into s power m by n factorial into m factorial, that is equal to right hand side becomes integral minus infinity to plus infinity e power 2tx minus 2a square plus 2sx minus s square into e power minus x square dx. Okay, so we got this. Now this is nothing but, the right hand side is nothing but now integral minus infinity to plus infinity e power minus x square, and when you take 2x common, that becomes 2x times t plus s minus of t square plus s square dx. Now adding and subtracting t plus s whole square on the right hand side, we get double summation n running from 0 to infinity and summation m running from 0 to infinity integral minus infinity to plus infinity e power minus x square hn of x into hm of x dx equal to t power n into s power m divided by n factor into m factorial. That is nothing but integral minus infinity to plus infinity e power minus x square and then plus 2x into t plus s minus of t plus s whole square plus t plus s whole square, the original term minus of t square plus s square dx. Now this becomes integral minus infinity to plus infinity e power minus of x square minus 2x into t plus s plus t plus s whole square. Considering the first three terms in the first bracket, taking minus comma and expanding the last two terms, that is t square plus s square plus 2ts minus t square minus s square. So t square and s square get cancelled and we are given only with 2ts. So that is nothing but now integral minus infinity to plus infinity e power minus of, because, and the first term can be written as difference of two terms whole square. What is the first term? X minus, what is the second term? T plus s whole square plus 2ts. Now e power 2t times dx e power 2ts is independent of x. So e power 2ts comes out. Integral minus infinity to plus infinity e power minus of x minus of t plus s whole square ds. Now put x minus of t plus s is equal to y. Therefore dx becomes dy. So this becomes e power 2ts minus infinity to plus infinity e power minus y square dy. And we know it is a standard integral. Integral minus infinity to plus infinity e power minus y square dy is nothing but root pi. So this becomes e power 2ts root pi. So root pi comes out. Now e power x can be written as a summation of an infinite series. So similarly e power 2ts can be written as summation 2ts whole power n by n factorial, because e power x equal to what? Summation x power n by n factorial. So this becomes 2 power n root pi by n factorial t power n into s power n. Now we note that the powers of t and s are always equal in each term on the right hand side of 1. Hence, when n is not equal to m, equating the coefficients of t power n into s power m on both sides of 1, we have 1 by m factor into 1 by m factor into integral e minus infinity to plus infinity e power minus x square into hn of x into hm of x dx equal to 0. That is when n is not equal to m. Again, equating the coefficient of t power n and s power n on both sides, we get 1 by n factor 1 by n factorial integral minus infinity to plus infinity e power minus x square hn of x into hn of x dx, that is equal to 2 power n into root pi by n factorial. N factor get cancel each other. 1 by n factor into integral minus infinity to plus infinity e power minus x square into hn of x whole square dx is equal to 2 power n into root pi. So finally we conclude integral minus infinity to plus infinity e power minus x square into hn of x whole square dx is equal to 2 power n into root pi into n factorial. So we know the delta function, delta nm equal to 0 if n is not equal to m, and that becomes equal to 1 if n equal to m. So continuing results 2 and 3 with the help of delta function 4, we get integral minus infinity to plus infinity e power minus x square into hn of x into hm of x dx is equal to 2 power n into n factor into root pi into delta n m. I hope this is clear to one and all. Thank you for watching this video.